What do I do first?
You do. Well, I did 5 times 2.
Okay, so I'm gonna rewrite it. You may have done it in your head, but I'm gonna rewrite it, and I'm gonna put the things that are alike.
Wait, that problem isn't right.
Next to each other. What's wrong with it?
The problem says 5 times 10 squared in parentheses, and then 3 times 10 to the 8.
Yeah. Oh, yeah.
Okay, so you want me to erase this? Change the problem? Is that why maybe your answer is wrong? Let's just try it. Okay, so this should say 3 times 10 to the 8th. Okay, so I'm going to rewrite it, putting the things that are alike next to each other, meaning my bases of 10 with their exponents are next to each other and my numbers are next to each other. So now I use the commutative property of multiplication to rearrange them, and now I can solve. 5 times 3 is 15. And then when my bases are the same and I'm multiplying, what can I do to my exponents? I can add them. So 2 plus 6 is?
Wait, no, it's 8.
Oh, it's an 8. 2 plus 8 is? 10. Okay, and now I have 15 times 10 to the 10th. What's wrong with it? Could we raise our hand for me, please? Thanks, Connor. Okay, so I need to move my decimal. I need to move my decimal from here to here and get 1.5 times 10 to the 10th times, and what did I do? If I moved this thing 1 decimal space, what did I really do? If I go from here to here, what do I need? From a small to a big. I don't need a negative. I'm going from small to big. I need a 1. So I have to multiply that thing by 10 to the first, right? And now I have bases that are the same, so I can add my exponents. And I get 10 to the 11th. Okay? Zoe.
Number 25.
Can you read it to me?
1.744 times 10 to the 46.
36?
Yeah.
Okay?
And then underneath it.
So divided by?
Yeah.
Okay.
3.5 times 10 to the
3.2 or 3.5?
Oh, 3.2.
3.2 times 10 to the what? 28th. Okay? So now, again, I'm going to do the same thing. I'm going to say, I'm going to deal with these guys. Can I solve this? Yeah. Can I do it with long division? Yes, of course you can, because you're in 7th grade and you know how to do division with decimals. Can I also plug it into a calculator?
Yeah.
And what do I get? Who plugged it in?
It's 0.545.
Before I make any changes to it? Okay, so 0.545. Is that it? Is that it? 0.545. Okay, times. And now I have to deal with this piece. And my rule, if my bases are the same, and I'm dividing, what do I do to my exponents? Dakota? I subtract. So 36 minus 28 is? 8. And so I have 10 to the 8th power. Now, what's wrong with it? I need a number between 1 and 10. So that means I want my decimal to go from there to here. And I want my new number to be 5.45. So how do I go from 5.45 back to this 0.545? A negative 1. And then I still have this piece that I have to add in there. 10 to the 8. And now my bases are the same, and I'm multiplying. So I can add my exponents, and I get 5.45 times 10 to the 7th. This is my final answer. Okay? We're not doing it right now. We're doing math right now. Any other question that I can solve for you? Megan?
Number 23.
Number 23. Read it to me, Megan.
In parentheses, 1.6 times 10 to the negative 4, in parentheses, times, in parentheses, 3.4 times 10 to the 4th.
To the what?
To the 4th.
To the 4th. Okay? So the first thing I'm going to do is I'm going to rewrite it so that my numbers are next to each other and my base 10s are next to each other. Okay? So if I plug 1.6 times 3.4 into a calculator, what do I get?
I got 5.44.
5.44 times, and if my bases are the same and I'm multiplying, what do I do to my exponents? I add them, and negative 4 plus positive 4 is 0. And 10 to the 0 power is really a 1. So 5.44 times 1, which is 5.44.